Now, if I had wanted to integrate the opposite way around, things would have been just slightly different. I'm just going to set up the integral, and then we'll talk about where it came from when I look at the rules for limits. So if I wanted to go the opposite way, I would be integrating e to the x plus y. Instead of dy dx, it would have been dx dy. Now I would have gone back and looked at the region and noticed the outer limit was the y's, so the outer limit's numbers, so the bottom y would have been y equals 0, and the upper y I would have picked the highest y used, and the highest y used would have been y equals 1. Again, that's because this is the line y equals x, so this point would have been 1, 1. Now the x limits. If I want to do this, what I would need is from x equals to x equals. And what I notice is if I pick a generic place, any place in the interval, the lower x, the less x, is the line y equals x. Well, this is the line y equals x, so it's also the line x equals y. So I'd be integrating from x equals y over, and then over to the vertical line, which is x equals 1. So the item I would have been integrating is from y equals 0, and I'm going to leave off the y part, from 0 up to 1, and then the x portion would have been from y to 1 of e to the x plus y dx dy. And if I did the math out, I should end up with the same answer. Now if I look at both of these integrals that I did, you'll notice a couple of items. You'll notice when I set up the integral, again, the outer limits go with the outer d portion, and the outer limits must always be constants. The inner limits are based upon what the inner variable is. So if the inner integral is with respect to x, as the second version happened to be, then its limits should contain only constants or variable functions in terms of y. And so you'll notice in one case I had a constant and the other I had y. So if this is an x, if I'm doing dx, I don't want to see any x's in my final limits of integration. If the inner integral is with respect to y, as it was the first time we did it, then the limits on that integral should contain constants or variables in terms of x only. So notice if we went back, our outer limits again are constants. We had dy, so notice inside we have constants and things that contain x.